Alright, let's look at the homework 4.7, problem number 4. Alright, so we a right circular cylinder is inscribed in a cone with height h and the base radius r, and find the largest possible volume of such a cylinder. Alright, so let's do that. I already drew the picture. Right, then the first thing I would do is I'm going to come up with the equation for the line here on the xy plane. So that's just a trace of the cone with the xy plane, right? But this is actually fairly easy to find because we know that y-intercept is h, so we put that there. And the slope is, 1 would be r, and the rise is going to be negative h because it dropped down h. So it's going to be negative h over r x, right? So if you want, you can factor out h. So you're going to have 1 minus x over r. Right? Then volume of this cylinder right here. So this is the cylinder right there. Alright, the volume is going to be, so volume V, and which we want to maximize. Alright, so it's a cross-sectional area, pi, and I'm going to use x here. So here, I call that x, so radius is going to be 8, so pi x squared times the height. Right, height is determined by this function here, so it's y, which is y is right here. We can just plug it in here, right? So you can see that, let's see, I'm going to put h in front, that's just a number, and a pi is just going to be a number. Then you have x squared times 1 minus x over r, right? I'm going to distribute x squared to 1 and the negative x over r. So we get h pi, right, times x squared minus x cubed over r. Alright, so we have a function there. So we're going to take the derivative. So this is a function with respect to x. So v prime of x is going to be h pi, just a constant. Derivative of x squared would be 2x. Derivative of negative x cubed over r is negative 3x squared minus r. And this is equal to 0. Right? And one thing is, I'm going to actually pull out one of the x. You have h pi, and pull out the x. So x. So you're going to have 2 minus 3x over r is equal to 0. Right? Then critical numbers are, right, x equals 0 is one thing. Another one is you have to solve this. 2 minus 3x over r equal to 0. And this is going to be 2 is equal to 3x over r. Then you can multiply both sides by r over 3. So it's a 2r over 3, which is equal to x. Right? So we got 2r over 3. Right? And we know that 0 isn't going to be the one because it's going to be the smallest. But here, this is going to be the one that gives us a maximum. So let's find the volume for that. So volume at 2r over 3 is going to be equal to, so h is there, pi is there, and then you have to square that guy, so it's going to be 4r squared over 9, and then minus, and we have to cube that, so it's going to be 8r cubed over 27, and we still have r, so times r. Right? Let's simplify. Let's see, we have cancel r, and that will be squared. Right? So you're going to have, right, h pi, and r squared is here, and then you have a 4 over 9, so I'm going to write it as a 12 over 27 minus 8 over 27, right? So that's going to be, right, number would be, let's see, 4 over 27, 4 over 27, and I would like to put pi here, and then maybe r squared h, right? So let's type it in, right? It was 4 pi over 27 r squared times h, right? Submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.